Alright, day 7. What do we got? We got... Well, we've got those errors too. Maybe I should just make them go away. Like this... Like, why is this here? Like, can we figure that out? Okay, well... We know that start isn't used. Stored to lang. So everything is just kind of set to 0 here. Like, do we actually need that? Like, we're returning TGA data. All of these TGA starts. Outsize, value stored to outsize is never read. Is that one of those not used ones? Outsize is 0, then it's used there as a 0, then it's stored, and it's never in here again. Okay, well, what if we just don't do that? Actually, you know what? There we go, there's the 8 errors. Maybe there is I was thinking about Aseprite and all the stuff that we have here. We got these layers, we can turn them off. There's a lot of information contained in here. And if we could just read that, we could use it for more than just art. Like, you can mark a pixel and hide it, but then read it and use it for something, like alignment or whatever. And we don't get that with PNGs. So we probably at some point want to read the actual Aseprite file sooner than later. Do we have any to-dos in the meantime? Yeah, so we have that pixel gap, and we have some debugging stuff. But maybe it's more pertinent to actually do the correct loading. Aseprite file format isn't that hard. Aseprite file format. Files. Aseprite file format specification. So they do have a specification which is like pretty short. And pretty easy to read. Now, there we go. They do have zlib compressed pixel data, which... Does STB image have a decoder for that? Yes. Yeah, seemingly we do. If you use STB no PNG and you still want the decoder, there we go. So there is a decoder. Zlib decoder. Okay, well, zlib client used by PNG is available for other purposes. Okay, so we have that. zlib decode buffer. Alright, so stv image is still going to be useful here. And we can also decode the buffer with no header. Okay. Yeah, well, where would that happen? Well, it would happen here. Okay. So, what do we want out of it? We just want pixels right now. But there is other information available in the file which you can also use. Well, we want pixels, and actually, and not just the pixel, we want the whole texture. Pixels, decoded pixels, width and height. Okay, well, let's see. Let's see what we're even reading, actually, before we get into that. Also, these fail sometimes because, like, language support in the editor locks them or something. So I'm gonna comment them out. Pack separately. So we're gonna pack them separately at some point. But for now, I'll just comment them out so they don't get in the way. Okay. What are we working with? What's the data? The data is in file content. That. That's a lot of stuff. Is there an add to watch? Yeah. File content. Can we, like, cast it? Yeah. Okay, well, we're reading PNGs, so file content will start with PNG. Alright, so the first step, I guess, is to, instead of reading PNGs, is to read Aseprites. Aseprite. So in build, let's not forget to remove that. And let's just remove that and that. So Commando PNG is going away, Lemurian PNG is going away. Aseprites are staying. Alright. So file content. Yeah, that's fine. Okay, now what's the file content? Alright. So we read an Aseprite file, so presumably, what's the path? Commando Aseprite, yeah, that's the correct path. And those are the bytes it starts with. V86 to, alright, well, let's see, what's the reference? Yeah, introduction. Why does it go up when you press escape? Color presets, palettes, well, we don't have paletted anything. Read the header. For each frame, read the frame header. For each chunk in this frame, read the chunk. What's the header? Header is that. File size, so it starts with file size, and then it's the magic number, A5E0. So, like, this is the file size, and this is like A5G0 or whatever. Alright. I mean, we know everything's a little endian, presumably, so we don't actually need to do a huge... Okay, we kind of have to take our type defs out, though. Otherwise the debugger doesn't work. Yeah, we'll leave these two in here, I guess. That's fine. What do we got here? We got memory. Memory. Well. Aseprite, I guess. Alright, all of this is gonna be a struct. File size. Magic. Frames, I'm guessing this is frame count. Width in pixels, well, yeah. Width, height. Bits per pixel. Well, yeah, okay, we'll do that. Flags. One layer opacity has valid value. Okay. Word speed. Milliseconds between frame. Deprecated. Dword set to be 0, 0. Set to be 0, 0, 2. Okay, byte palette entry. Index which represents transparent color. Palette entry index for transparent color in all non-background layers, only for index sprites. Yeah, okay. Byte 3, ignore these bytes. Word, number of colors, color count. 0 means to 56 for all sprites. Pixel width. Pixel ratio is pixel width over pixel height. If this or pixel height field is 0, pixel ratio is 1 to 1. Pixel width. Pixel height. X position of the grid. is grid X position, grid Y position, grid width 0 if there is no grid. Grid size is 16 by 16 on Aseprite by default. Okay, well, grid size, oh, grid width, hold on, grid width, and grid height. And byte 84 for future. Type def struct Aseprite, ace, I guess, header, like that. And all these D words and whatever can change to U32 words, just U16s. I mean, there is a reference here. D word is 32, word is 16, yeah. Byte, 8-bit unsigned, so U8. And short, 16-bit signed. Okay, what are these errors? Brackets are not allowed here. What brackets? Oh yeah, these brackets. Okay, well now we can just cast it. Ace header is ace header cast file content, and we can do an assert that the magic number is 0xA5E0. Okay, what's the breakpoint key again? It's like F9, yeah. Add to watch. File size 598. Well, yeah, that seems correct. Magic. Well, I mean, does this actually give me 42464? Yeah. Frame is 1. That seems correct. Yeah, that's correct. Flags. Yeah, those are zeros. Ignore. Color count, pixel width, pixel height. Okay, so what does this mean? 16, 16, 0, 0. Do we care, actually? Do we care? Grid width 0 if there is no grid. Yeah, there is no grid. Okay, well, yeah, we don't really care about the grid. Frames. Each frame has this little header of 16 bytes, alright? Type def struct ace frame header. Bytes. Magic FIFA. Old field which specifies the number of chunks in this frame. If this value is 0xff, we might have more chunks to read in this frame. So we have old, well, I guess chunk count deprecated. Frame duration. MS. For future. New field. Okay, so chunks count. If set to 0, use the old field. So it's not really deprecated, right? It's like you either use this or that. Okay, well, just make these things like 64 bytes or something. D word is U32, word is U16, and byte is U8. Okay, well, we have a frame count, right? So like 4. What's the frame count? It's a U16. Well, I mean, whatever. Frame index is 0. Frame is less than ace header. Frame count. Frame index. Actually, I think we need to pack these things, right? So this is like pragma pack or push. What's the correct? It's like clang pragma pack push. What's the syntax for that? Pragma pack push, pragma pack 1, pragma pack pop. Yeah, okay. Was this pragma, and then you do pack, and then you do push, clang, pragma, pack. What is this stuff again? It's like, I'm guessing you give it in the alignment. Is there like a latest version of this? Clang user manual. 18. Okay, well, fair. Back. Okay, it does not contain anything about. Is this like just a compatibility thing for the Windows compiler? I hate RISC. Okay, Raymond Chan has a problem with Pragma Pack 1 to byte packing. Okay, Pragma Pack, so it's more of a Microsoft compiler, I guess. Okay, SDN Pragma Pack, Pack Pragma. There we go. Pragma pack push pop. Okay, so we want n. Okay, n is yeah. Okay, 1. Yeah, so that's the alignment essentially. Pragma pack 1, and then pragma pack pop, like that. Does that compile? That compiles. Okay. I guess we should verify that it actually is working. Struct temp u8 v1 u32 v2, and here we're just gonna go int temp is size of temp struct temp. Oh wait, we already have a temp, I think. Wait, do we? Oh yeah, wait. God. What? Why is this failing all of a sudden? Oh, I don't have a terminating cycle. Yeah. Okay, so what's the size of this? Temp is 5 bytes, yeah. And if I just take it outside, then it's 8 bytes. Yeah, okay, so pragma-pack is working. So that's good. But anyway, so we want to iterate through. Comes the frames data. Well, I mean, I guess frames data would be like void star frame data is file content plus size of ace header. Okay, so that's where the frame data starts. So now we can do ace frame header. Frame header is cast frame data. Frame header, add to watch. Bytes, magic, yeah, we need to assert frame header magic is 0xf1fa. Yeah, we don't even need this x then. Okay, there's magic, chunks count old, chunks count new, so sometimes they're the same. Or maybe all the time they're the same. I guess for new files, this is always the field we should be using. Okay, so let's use just the new field for the chunks. So what are we supposed to do actually? So this is the chunk size, chunk type, chunk data. Okay, so for i32 chunk index less than frame header chunk count chunk index. There it is. Well, by the same token, I mean, I guess there is chunk data, right? Chunk void star chunk data is frame data plus size of frame header. Well, not the variable, the type that. All right. And dword chunk size, dword chunk type, and then it's just the data. So dword is U32, chunk size is, it's dereference, cast as a U32 pointer, chunk, I mean, I guess we could just cast as a, just do this type def struct ace chunk, and what is this? Oh my god, what is this? It's U32 chunk size. Then it's a word, U16 type, and then it's byte array, so U8 star data. I mean, star. So ace chunk is cast as an ace chunk. What are we casting? Chunk data. Okay, so there's the chunk. Now chunk data, so for each chunk data needs to be advanced by chunk size, and for each frame data needs to be advanced by, well, I guess it's advanced by the same amount. Or wait, so chunk data is advanced for each chunk, and then once we're done reading that, it's the next frame. So we can just do frame data equals chunk data. Yeah. Yeah, so that's pretty much it for parsing the file. We have the chunk data. Now, what are the chunk types? Old pallet chunk. Ignore this chunk if you find a new pallet chunk. Well, we don't have pallets, so we don't expect to see these. Layer chunk. If the first frame should be a set of layer chunks to determine the entire layer's layout. In the first frame, a set of these. Okay, well, let's just see what kind of chunk types are we even getting. Chunk. Add to which? Size, type, chunk type X. Do I need to use an arrow here? Yeah. 2007. Color profile for RGB or grayscale values. no color profile, use sRGB, use embedded ICC profile. Okay, so we kind of want to just use sRGB if we encounter these. Type def enum ace chunk type. And type is, what is the type? Actually, it's a U16. Yeah. What's this color profile? Comma? Yeah. And might as well type it, right? I think we can type them like that. Does that compile? Wait. Right. Does that compile? That compiles. So I think we can just type this. I think. Well, I mean, let's see. Size of ace chunk type. Temp is 2. Yeah, so it's working. Okay, so color profile is something that we are actually seeing. So switch chunk type. Of course, IntelliSense is not picking this up, and syntax highlighting is breaking because MSVC just does not understand this valid syntax. Case that default assert unimplemented. I mean, we can make the index the same type, like that doesn't really matter. Okay. Chunk type. Okay, well now we don't need an X, whatever. Well, actually, kind of. Color profile, right? At least the debugger is working. Okay, 2019 is the next one. Palette chunk. We don't have a palette. Why is there a palette chunk? I guess we're just gonna ignore the palette. Color profile, palette, 004. Old palette chunk. Okay, we're getting that as well in there, okay. Old palette. I mean, I guess we're just gonna ignore that as well. Just put everything we're ignoring. Palette. Actually, do we have a palette? Okay, color profile, palette, old palette, then it's 2004, which is layer. Okay. Layer is something we need to handle, probably. Color profile, palette, old palette, layer, 2005, cell. Color profile, palette, old palette, layer, cell. Oh yeah, we don't have the handling of it. Okay. Cell is something else we need to handle. Color profile, palette, old palette, layer, cell, and that's it. Okay. Okay, let's color profile. What does color profile tell us? Okay, well, actually, let's see. Type def struct ace chunk. What is this? Palette? No, okay, color profile. Okay, all of this. Okay, word is U16 fixed. Fixed. What the hell is fixed? 32-bit fixed point value. I guess fixed 16x 16. U16. That's what's fixed is. If sRGB is specified with a fixed gamma 0, it means that it is linear sRGB. Okay, well, the phrase linear sRGB doesn't really make any sense to me. But, okay, well, we'll see what kind of data we actually get. Flags. Type. Yeah, we'll just type. Let's see. Color profile. Fixed gamma. Byte U8 reserved. Dword ICC profile. Data length. Oh, I mean, I guess struct dword is U32 lang, and then just the void star putter ICC. But this is like optional, right? Okay, so that's the color profile. So I guess like in here we can even, instead of doing a void, well, I mean it is a void star. It's less of a void star and more of like a union. Color profile. So this tells us what it is, right? And then here it's like yeah, we can like precast it pretty much. Yeah, okay, let's stop there. What's the chunk? Okay, apparently color profile is unable to read memory. Somehow. I mean, the thing that comes after type is the data. And if the type is color profile, then the data should be color profile. Why is this like 001? Like, what's that all about? Alright. Okay, so chunk has a size, a type, and data. Let's go very low. Yeah, each chunk format is just that. Chunk data. Chunk size includes the dword. Wait, chunk size, hold on. Chunk size includes the dword of the size itself and the word of chunk type, so the chunk size must equal 6 bytes at least. Yeah. Well, might as well put an assert in there. Chunk size is greater or equal to 6 bytes. Yeah, well, size is 22, which is like... color profile, is it? I mean, that's... okay, that's weird. Hold on. Data. Can you do this? U64 chunk data. 1? Oh wait, wait, yeah, hold, yeah, this is not, yeah, of course, this is not really a void start date, this is that we need to cast that offset specifically. Alright. So it's not, oh my god. I guess this is really a chunk header. Switch on the type, and then in here we would have to go in and say, okay, okay, chunk data is that. I guess it's more of a chunk content situation. Chunk content is chunk data plus size of chunk header. There, and here we need to cast the chunk content, that's what it is. Yeah. Content is, well, I mean, this is gonna be that. Content is chunk content. Type flags gamma. Okay, assert content type 1, which is like useless RGB or something. Chunk data plus equals chunk size. Well, chunk header, because it includes the header. Okay. Okay, well, there we go. Now we can add this to which. Don't care about that, don't care about that. Chunk header is probably something that we do want in watch. Yeah, chunk header, size 22, it's a color profile. So we go in here, cast it as a color profile. Okay, type 0, flag 0, gamma 0, reserved, all zeros. Okay, so what's type 0 in color profile? No color profile, as in old Aseprite files. Really? No color profile? I mean, this isn't an old file. So why would this be no color profile? Like, I mean, is it something like that you like set here? Color mode, RGB color. Well, yeah, RGB, more options. Indexed, grayscale, merge, like cancel. Place color. So somehow this is, I mean, we're technically reading this one. Interesting. Color mode. Well, I mean, there's RGB, grayscale, and indexed, right? I guess there's no color profile sRGB. Like, it's not none. Display profile sRGB, color space profile. And why are these two the same? Like, what is the difference between these three? Exactly. Okay, well, I mean, what we are getting, content, size of chunk header, so the next thing is the content, and it's just zeros. And these things that are set to 0 don't seem to be set to 0. Like, we've got this 218 in here. Okay, where is that color profile again? Gold balance, layer, cell, color profile. No color profile. Use sRGB. Use embedded ICC. I mean, we. Okay. Well, there's no useful information here. Okay, let's just assume that it's what it's supposed to be. No color profile, so we can ignore it. So we just don't do anything. What's the next one we get? The next one we get is palette. Again, we don't have a palette. Which palette is this? No, this is not old palette. This is new palette. Palette. I mean, we could just ignore it, like we don't have a palette. So let's ignore palettes. There's also an old palette, which we're also ignoring. Layer. Okay, layer is something we cannot ignore. Layer. Should be a layer of chunks to determine the entire layer's layout. Yeah. Type def struct ace chunk layer. Okay, word is U16. Flags. Okay, well, we're gonna copy that later. If we need to, flags. Type. Child level. Default layer width ignored. Default width ignored. Default height ignored. Blend mode. Always 0 for layer set. Okay. Byte U8 opacity. Valid only if file header flags field has bit 1 set. Oh, that flag, those flags. Okay. This is U83 future. String layer name. Okay, what's string? Word string length and then byte length characters. A string name type abstract ace string word u16 length and then char pointer. I mean, it's not really, I mean, str, I don't know, something like that. See if that displays correctly. Okay, future a string name. If layer type 2, well, we also might have this. U16 tile set index. Okay. Okay, so if it's a layer, then layer content chunk content. Content flags is 0. Let's just do some kind of an assert from there. Okay, so content flags, it is 0. Blend mode 255. Type 0, opacity 0, future, name. Okay, well, this is not, like, seems like there is, like, we're missing something, or it's like off a little bit. Because this year 1m, it's supposed to be layer 1. Actually, what kind of string is it? UTF-8, character 0 is not included. So not null terminated, so string length. Okay, well, that's clearly wrong. Okay, so something's clearly wrong here. Oh, well, what's wrong is that I meant to include that step. Okay, so let's look at the palette again, or color profile rather. Type 1, yeah, so that's kind of what I expected. Okay, so assert the type is 1, which is used as RGB. Might as well include that. Okay, color profile. Okay, these are the types. Type. I guess this is a scalar profile type. Well, and that's a U16. This one. Okay, so this one is none. This one is sRGB, and this one is ICC. Okay, so type is a scalar profile type sRGB. So assert that it's an sRGB. What do we got here? We've got layer. Okay, let's see. Yeah, so that's an sRGB, that's all good. Alright. Layer 1M. Well, 7. 1, 2, 3, 4, 5, 6, 7. So it's up to here. Layer 1. Yeah, that's fine. Content flags. Okay, what flags do we got? That's not 0. No, it's not 0. Layer check. There it is. Flags. Okay. Type def enum ace. Well, it's not these flags, it's layer flags, right? Ace layer flag. Type def ace layer flags is a U16. Okay, visible, editable, lock movement, background, prefer, linked, cells. A layer group should be displayed collapsed. Okay. Layer group should be displayed collapsed. A layer is a reference layer. Do we have bit sets in C? Or is that something else? I mean, there is that in C++, but you know, we don't do that here. Yeah. Bit set class. I thought there was something. Something like that. 9 years. No, it's something more recent. I mean, yeah, you can do it the sort of the manual way, but like that. Maybe there isn't. Maybe it's something else I'm thinking of. Ace layer flag, ace layer flags, flags, yeah. So I think we had this visible and editable. Yeah, alright. Okay, so tile set index. Okay, so we have this optional field, which we are... So it's only present when profile is ICC, but we are inserting that that's not the case. We also have this optional tile set index. I mean, actually, since we're not using the size of these things, we don't actually need this to be like a commented out thing. We could just have it in there. All we are doing is oh yeah, variably sized thing is not at the end. Is a GNU extension? Well, yes, but you know. But so what? Use the GNU extension, I don't care. Does it still work? Yeah, so tile there, we can just ignore that. So that is our length, that is the okay. Alright, now flags, we don't really, so if type is 2, yeah. So type was normal, group, and tile map. Alright. This is layer type. Ace chunk, ace, layer type. Normal, group, and tile map. 0, 1, 2. Let's just make it explicit. 0, 1, 2. Ace layer type. Enum. So, and that's a U16 as well. Okay, so that is the ace layer type. And what did we get out of that? Normal. Yeah. I mean, I guess we can just assert that that is the case. Type ace layer type. Assert that the type is normal. Child level cnode.1. The child level is used to show the relationship of this layer with the last one read. I mean, that does make sense, yeah. I don't think we'll be using that though. For now, default layer level, this is ignored. Blend mode, always 0 for layer set. Do we care? Do we care about blend mode? Not right now. Opacity. That's this. Okay. Future name. Tile set index. Yeah, so the first frame just has these things. Okay. Well, we only have one layer. And this is where we can pull out information about what's visible, for example. And how to blend them. I mean, I suppose we don't really, like, if we're gonna use layers, we're probably not gonna be using them with transparency, so we can just, like, overwrite. So instead of, yeah, we can just ignore the blend. Because we're not gonna be doing our own blending of that kind, probably. Unless we do want to do that, in which case, maybe we will. But that's it for the layer. What's next? Yeah, alright, so we've got color profile, palette, alt palette, layer, cell. Okay, I think this is the main one, really. Where to put a cell in the specified layer. This chunk determine where to put a cell in a specified layer. Okay, this is the actual image data, finally. Type def struct ace chunk cell. There we go. Okay, so we've got layer index as a U16 index C node 2 number to identify layer in a sprite. Yeah, we don't really care about that too much. Short, I mean, short is a U16. Or is it an I16? No, it's not, it's an I16. X position, Y position, yeah, that's... Opacity level, byte is a U8. Cell type. Type def enum ace cell type. Well, raw linked compressed tile map. Okay, so compressed image and compressed tile map. That's really what it is. And what is this, word? Yeah, so words are U16s. And so this needs to be a U16 then. And then we just go cell type is one of those. Type. Okay, got all that. Z index, C node 5. In case that you read and render an Aseprite file, you are going to need to process the Z index for each cell with a specific algorithm. Of each, basically, so what is this? Layer, struct layer, layer Z index. In Z index. Yeah, so what we first compare layer plus Z index of each cell, and if this value is the same, we compare the specific Z index value to disambiguate. Okay, I mean, yeah, but I don't think we care about that right now. So Z index default show later show Z index. I mean, it seems like Z index offset really. That's what it is. For future again. For cell type raw. For cell type 1. Okay. Union. Struct raw. Width and height. Now width, height, and then raw pixel data. Can I just do like U8 pixels like that? Actually, it's not a U8, is it? It's a pixel. I mean, pixels are variable, right? So yeah, let's just raw header. Let's just do a header. Well, actually, header. Like that. Header raw. There we go. Okay, so we've handled this. Top to bottom for each scan, yeah. Linked. U16 frame position to link with. I don't really even know what that is. Probably not important. Extract compressed image. Okay, so compressed image is actually the same as raw or compressed. Oh, I mean, I guess we can just use image or something. Image dimensions. Actually, yeah, maybe this is what we want. Raw cell compressed with zlib method. And for cell type 3, compress style map with all these things, but you know what, we're not going to be using that probably, so let's just ignore that. I mean, we're not really using this either, come to think of it, so maybe just remove the union. Yeah, we're only parsing this stuff, so that's all we need. Width and height. and we're just gonna assert that that's what we are parsing. Assert, well, first of all, cast as the correct thing, which is wait, hold on. This immediately what? Hold on. Yeah, we can just put that data here. Header, frame header, chunk type, ace chunk. Yeah, it's just all the chunks. Ace chunk color profile. Then layer. And cell. Yeah. Yeah, that's it. Color profile, layer, cell. There's also palette, alt, but we are skipping those. Okay, so now we don't really need to do this, all that, all this. So we'll just go chunk. Okay, so it's not a chunk header anymore, it's just a chunk. We don't need this. Chunk. And then here we just go chunk. Color profile. Here we go chunk. Layer. And here we go assert chunk cell. You know, type or whatever. Yeah, type is compressed image. That's what we expect to see. Okay. Okay, let's go in. So that we don't have anymore. We do have the chunk though. Add to watch. Okay, type color profile. sRGB. That's all good. Type palette ignore, all palette ignore, layer. Layer normal, flags like editable, visible. Name layer around, so that's all good. Tile set, yeah, we're ignoring that. Okay, next. Cell. Cell, okay, index 0, position, position. Okay, so these positions are interesting. 1320. Oh, so it's just, I mean, we can do that ourselves instead of relying on whatever this is supposed to be. Type, width, height. I mean, that's interesting though, because it doesn't actually store the whole thing. Like, it doesn't store the whole 32 by 32, it only stores this part and compresses it. And it just tells you where to place that thing. So you don't need to trim anything then. It only stores what you've drawn, and it doesn't store the empty space. That's good. It is compressed image. Yeah, so so that's enough information to be able to uncompress it. So like here, we can get the image data. Void star compressed data is chunk. So it's a void star. So if we cast the chunk pointer to a void star and then just advance it by this much, that should be the start of the compressed data. And the length of the compressed data is just, well, we know how big the chunk is, which includes the header. So, you know, like U32 compressed data size is, well, it's chunk size it's the whole size, but we want to subtract we're subtracting what? We're subtracting this, and this. Size of U32 minus size of base chunk type minus size of ace chunk cell. Okay. U32 non-data. Let's just add these together. Size. Then assert, then chunk size is at least that. Then U32 compressed data size is chunk size minus non-data size. So it's that. And now we can pass that to that. Decode buffer. Output buffer, I'm guessing, which is this texture, right? So did we do anything with the texture up to this point? No. Decode buffer. Well, for now, let's just do this. Pixels is arena. Well, I mean, we do know how big the image is, so we actually know exactly the buffer that's needed to decode that. So like texture. Well, I mean, this is just one of the cells, though, right? Yeah, this is just one of the cells, which in this case we're probably going to have only one cell anyway, because we have one layer, and there's this one thing within that. And that's probably going to be true for every frame. So, like right now, we have frame has chunks. Yeah, we can treat each of these cells as a separate image. Yeah, let's just do that. Well, texture width is chunk cell width. Texture height is chunk cell height. Texture pixels arena alloc array. Arena type is u32 and count is texture width times texture height. Well, there we go. So there's the input buffer, the output buffer. Output length is that. Input buffer is compressed data, and input length is compressed data size. So that times height times size of u32. Okay, it returns an int. Presumably it's like the size of the... Okay, so -1 means error by the looks of it. Int decode the result is that, and then assert, I guess, that decode result is the size of the texture. So that u32. I mean, well. So this is how many bytes it decoded, I think. Let's find out. Okay. Okay, decode result is -1. No, it failed. Is it because there is a header, or... Well, let's find out. Do zlib, parse zlib, parse header. Yeah, that might be the problem. No, bad header. Flag in 32, no. Return if not parse zlib header, return 0. Yeah, okay, well, let's just do that again. Okay, so these are just all zeros. If this isn't 8, return bad compression. Okay, so something's definitely wrong with that first. Hold on, let's raw pixel data, compressed, cell type link, compressed with zlib method. Okay, let's actually, there is a note. Uncompressed image as saved like that. When an image is compressed, data is a stream of bytes in the same format but compressed that way. Yeah, so is there a header involved? Compressed data. I mean, hold on. Is everything up to compressed data at least correct? Chunk data. Cell, okay, position 1320 and 912, so 29, 13 plus 19, 32. Okay, so the numbers do make sense here, so, which makes me think it, so everything up to compressed data is probably correct. Hold on, compressed data is, so data starts, so the chunk, hold on, where's the chunk again? This is the chunk. Ah. Yeah, so that's not where the compressed data starts. Compressed data size should be essentially that. Compressed data is that plus non-data size. There. And compressed data size is the total size minus. Alright. Okay, let's see, let's decode the result. 432. Okay. So pixels in texture is that. So bytes in texture is pixels in texture times size of u32. Bytes and texture is 432. We decode the result is 432. Okay. So let's decode it into a texture. And it is at this point that we probably want to push the texture. So instead of pushing it here, we're gonna push it here. Which means that the texture isn't actually initialized here. It's initialized for, I mean, I guess for each chunk. Well, I mean, it's only here really that we use it. So whenever we see a cell, okay, we're not doing that anymore at all. Okay, so texture width, texture height, texture pixels. Okay, well, so the whole point of this is to just create a texture array, which is what we're doing. Alright. There it is. Okay, so chunk size definitely should be greater than 6. Whatever happened here? Chunk index is 5. Chunk, oh my god. Okay, something definitely went wrong there. Frame header. Chunk counts, all chunk counts, well, both of these are wrong. Frame header bytes, magic. Yeah, that's just whatever happened here. Whatever happened here. What's the ace header saying? Well, what's the path to the file? So that's still the command to file. Okay. And frame index is 0. Frame header is wrong, though. Wait, what? How did we even get there? It's like, okay. Frame index 0. Chunk index 1, 2, 3, 4, 5. Frame header changed. Okay, what? Okay, let's just. Oh, what? Oh my god. The wrong button. Let's go ahead. Some kind of cell. Oh, we overrode. It's not. Wait, no. No, this is fine. Why would this overwrite anything? I'm not giving it a buffer. I'm not giving it a buffer it can overwrite. What? Is the debugger even displaying correct information? 1, 2, 3, 4. Size 77, type cell. Compressed image, 912. Why are there 4 of them? Header gets overwritten. Oh wait, did I? That'll help. Assert file size quad part is smaller or equal to enough free size. Why are these erroring now? Did I remove something by pressing a button I didn't mean to press? What? Oh yeah. What? How did this? Okay. And the fact that it was working before is interesting. Okay, well, frame index 0, chunk index 0. Then we've got color profile. That's frame index 0, chunk index x1, palette, alt palette, layer. Okay, then we went on to the next one. Free base CPP. Actually, what happened? Okay. Oh yeah, it should just fail because here. Because I'm not using that application anymore. Yeah. All right. I need to clear it to something. Well, I need to pull these apart a little bit. Pull these apart a little bit and clear the screen to something that's not black. 3. Alright. Where is that movement delta? It's rendering. There's the update. That's probably too fast. Yeah. Yeah, so there's no gaps. But that's, you know, that's full either. Okay, X, Y, X, Y. It should be, what? Yeah, I want them to be standing slightly further away from each other. Okay. Well, let's see what we've done here. And, well, STB image. What other defines do we have? Only PNG, only... Ah, there we go. I mean, we kind of want to know everything. Let's see, does that work? Yes. A bunch of warnings about unused parameters and such. How to push diagnostics again? Pragma diagnostic push. Pragma GCC diagnostic. Yeah, so it's just Pragma clang diagnostic push. Pop, and then like unused parameter or whatever. Okay, there we go. Yeah. Got rid of the warnings. This isn't necessary anymore, so we can just remove it. That does need to be packed separately. I mean, like, for now, let's just comment them out. And leave them commented out. Yeah, so that's the Aseprite types. That's Aseprite parsing. Not freeing anything. Yeah, just move them around a little bit. Make it move faster. Make the background color be different. Okay. And I changed this Lemurian Aseprite file a little bit. Okay. Parse Aseprite files directly. Okay. What time is it? 16:17. Yeah, well, this is all for today. Thanks, everyone.